See, actually, I'm going to just quote what is popularly accepted, okay, in the industry, especially from a machinery perspective. There is a huge chasm or a big difference between the efficacy of mixing in a dispersion needle to that of a intermeshing or tangential machine. The difference is quite huge. Okay, there is one empirical study which says that on a scale of 10, if the dispersion generated by a dispersion needle is about 5 on 10, it is closer to 9.5 or 10 in an intermeshing kind of equipment. That is the empirical evidence. Okay, and that there's a lot of research that has gone in. Okay, however, because of obviously the scale constraints and so on, for an SME, he cannot really go in for the intermeshing or tangential because the price differential is about 6x or 7x in terms of investment. Okay, and he does not have the volumes to recover that capital investment because the huge mixers which are there, it is like that typical that asura which can grant you all the wishes, but you have to keep on giving it food, otherwise it will eat you. Okay, so an intermeshing machine or a tangential machine is like that asura. If you give it enough volumes, it will generate excellent outputs. Okay, but if you starve the machine from volumes, the investment will kill the business. Okay, so that is the kind of a trade-off. But the truth of the matter is, dispersion needle can generate at best 5. Intermeshing can touch 9 or 9.5 or 10. So dispersion quality is far superior. What I've seen from my own experience is that parameters like tensile and even hardness, there we have seen difference when it is mixed in the same formula, same ingredients, same everything. When it is mixed in the dispersion needle versus intermesh, we have seen the difference in tensile. Okay, not only have we proven it from our own experience, our customers have also validated that. Okay, so this is all kind of proven. Okay, that is one part. The other part is that when you talk about the choice of equipment, just like you have your mobile technologies between GSM and CDMA, which was there are two popular technologies to choose from, and that essentially comes from rotor design. One is basically intermeshing and one is tangential. Okay, the tire industry, when there is the variety is not more, because tire industry has only a bunch of compounds and they want volumes because tangential can have a much better fill factor in the equipment. So economically it is cheaper. The mixing cost per kg is cheaper in a tangential. In intermeshing, it can generate much better dispersion than tangential. That is all the research which is indicating. Lastly, I would like to point out one thing. There are certain infeasibilities. For example, supposing you have a compound which is fiber reinforced compounds, where either you are putting a cotton fiber or aramide fiber or nylon fiber. It is simply not possible to generate and mix properly in a dispersion needle. It is not possible. It is not feasible. Okay, you definitely need advanced technologies like intermeshing and so on. So this is the unfortunate reality. The moment you have infeasibilities like that, for an SME, those classes of products which requires fiber reinforcements, it becomes infeasible for him to produce. It is out of his purview because he does not have the technology to mix those kinds of complex compounds. Okay. Then from a processing perspective, it is quite complex again. When you talk about the standard operating parameters, temperature control becomes very important. Okay. Then you have pressure. The ram pressure also plays a part in the dispersion. And there's a big difference between whether you choose a pneumatic ram versus a hydraulic ram. There's a huge difference, okay, in controllability. And then there is the variable speed. Okay, even the speed of the rotor has